Light travels really fast. It's so fast that it's quite difficult to determine a value for the speed of light. But it's not just the speed of light that is important, this value also appears in other places like the energy to mass equivalence principle. So how was the speed of light calculated? In ancient times, many scientists believed the speed of light was infinite and could travel any distance instantaneously. The Italian physicist Galileo Galilei was among the first to try to measure the speed of light. When Galileo's name comes up, most people think about his contributions to observational astronomy. However, he did lots of other stuff including investigating the speed of light. During his time, many people considered light just to be some instantaneous thing that didn't have a speed. Here is Galileo's method to measure the speed of light. Take two lanterns at night and separate them by a large distance but not too far that you can't see them. The two lanterns are held by two different people and they have a shutter so that you can essentially turn them on and off. Of course, this isn't a very useful method to measure the speed of light. Let's say that I can put a lantern 1 kilometer from the observer and it can still be seen. The time it takes light to travel there and back is insignificant compared to the human reaction time and at the other end. Oh, add to this the problem of keeping accurate time. This method might work to measure the speed of sound, but not for light. In the end, Galileo's value for the speed of light was at least really fast. Around 1676, Danish astronomer Ole Romer became the first person to prove that light travels at a finite speed. He studied Jupiter's moons and noted that their eclipses took place sooner than predicted when Earth was nearer to Jupiter and happened later when Earth was farther away from Jupiter. Romer reasoned this was the result of light moving at a finite speed. It took longer to make it to Earth when Jupiter was a greater distance away. In the ensuing centuries, a number of other scientists worked to determine the speed of light and, using improved techniques, came up with increasingly accurate calculations. French physicist Hippolyte Fizeau is credited with making the first non-astronomical measurement, in 1849. Using a method that involved sending light through a rotating toothed wheel then reflecting it back with a mirror located a significant distance away. The idea is to adjust the speed of the spinning wheel until you can't see the reflected light at all. Perhaps this is easier to see if I replace the wheel with a long linear strip of teeth. Now imagine that the teeth let a short pulse of light through before blocking it again. This light travels all the way to the mirror and back to the teeth. What if in that time, the teeth have moved down enough to block the eye? Then when the tooth is no longer blocking the eye, it is blocking the light. So by knowing the speed of the teeth and the size of the teeth, you can get a value for the blocking time. With the distance to the mirror and back you can calculate the speed of light. One of the first precise calculations of light's velocity was made in the 1920s by American physicist Albert Michelson, who carried out his research in the mountains of Southern California using an 8-sided rotating mirror apparatus. In 1983, an International Commission on Weights and Measures set the speed of light in a vacuum at the calculation we use today, 299,792,458 meters per second, 186,282 miles per second, a speed that could circle the equator 7.5 times in a single second. Thank you for watching the video. See you in the next science video. Don't forget to like the video and write your thoughts in the comments section. I'd appreciate it if you'd subscribe to my channel.